Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 1 of a unit Laws of Motion. So let's begin with today's class. In today's class we are going to just discuss the introductory session of laws of motion. So before we start with the laws of motion, let's first find it out. What is force? So how can you define that? In the classes, maybe in ninth class or 8th class somewhere, we have been given definition that it is a push or a pull on an object which generates or tends to generate a motion in a body at rest, and or if object is already in motion, it can make it rest, or tends to stop a body, or tends to change the shape of the body. So this is what we call as a force. So according to this definition, what force can do all these things? It can make a body in motion, it can make a body to the rest if it is already moving, or it can change or tends to change the shape of an object. So these three primary things can be done by applying a force. Now when we apply a force, we need to consider that whether it is an internal force or an external force. Now let's begin with what is internal force. We can say internal force is that if the force is applying and on the system, and the applying agent, that means the force applying agent, is inside a system, then it is known as the internal force. But this force cannot provide a motion to the system. Let's suppose understood that this is the system, and let's say this is block A and this is block B. Now let's suppose block A is applying a certain force on block B. So block A and block B, we can say block A and block B are part of system. So this force is considered, this force is considered as internal force. Yes, this is the internal force of an object or internal force of a system, and with application of this force you cannot move this system as a whole. Yes, this is the limitation, that internal force cannot drive the system. Let's have a look. That let's suppose if you are sitting in a car and you are about to push it, that you yourself cannot move the car, but if you came out of the car and apply the same force, then it will move. Yes, so this is, by this person a car is moving because it is the case of an external push, while you yourself sitting inside a car, the car does not move it because it's an internal push which does not drive the car. I hope this is clear. Is it? So is it clear what is internal force? Great. Now let's understand what is inertia. You have studied this in class 9 as well. So what does it? Inertia. When we say inertia, we always say it's a resistance to change. Whatever is going on, you want that it must be going on, and you don't want that is to be changed. That is what we call as an inertia. Let's say a ball, if it is at rest, it wishes to be at rest unless acted upon by a certain force. Yes, so this is what we call as a race inertia. Yes, okay. One more thing. Let's suppose one person is there. You want to you want to push him, and let's suppose one truck is there. You want to push him. So both are initially at rest, a person as well as at rest. So which will require a larger amount of force to move down? It means if you want to move a truck, you are applying a force, let's say F2, and if you want to move this person, you are applying a force that is of F1. So which force would be a larger, whether it is an F1 or F2? Yes, you understood that it is the F2. So what we understood by this, that in mass of an object represents the inertia of an object. That means if mass is higher, inertia would be higher, and vice versa. Yes, if mass is higher, inertia would be in higher. I hope these things are clear. Is it clear? Yes? Great. So inertia, we can even say that it's a special name for the inertia, which we call as a laziness. Yes, it's a day-to-day language. Do not write this in your examinations. Yes. So what we understood by inertia is, we have this kind of things. It's an, if things are at rest, then they want to stay in the rest. If things are in the motion, then they want to move on the same, they wishes to move with the same speed. That means they want to move, they want to be in the motion itself. And this is the Newton's first law is all about. What does it say? It says that every body continues its state of rest or its state of motion until and unless an external force is applied. One more time, it says that every body continues in its state of rest or its state of motion until and unless any external force is applied on it. Is it clear? Is it? So we are going to move back on this, but before we move back to this, let's discuss types of the inertia. Basically, we have three types of inertia. One is the inertia of rest. Another, it's an inertia of motion. And third, it's an inertia of direction. So we have three inertia: inertia of rest, inertia of motion, and inertia of direction. In the inertia of rest, a body is at rest and it wishes to be on same state. That is what we call as an inertia of rest. In inertia of motion, an object is in motion and it wishes to be on same state. That is what we call as an inertia of motion. And last, it's an inertia of direction. That means an object does not want to change its direction of motion. That is what we call as an inertia of direction. Is it clear? Is it clear? Is it? Great. So we have already defined the first law of motion. One more time, that every body continues to be in its state of rest or in uniform motion in a straight line unless and until it is compelled by some external force. And this law is also known as the law of inertia. Now here we want to clarify one more term, which is an external force. What is it? That we have discussed the internal force. One more time I am going to focusing on this. So let's have a look. Let's suppose two person are there and a third person is at here. Let's give them a name. It's a person A, person B, and person C. Now let's suppose person A is applying a certain force on person B. So this is F1, as the person A and person B are part of system, so F1 is considered F1 is being considered as internal force. Now let's suppose person C is applying a certain force. Let's give it a name as F2. Now as C is not part of a system, then force applied by person C must be considered as external force. Is it clear? Is it? So what is external force? What is internal force? Is it clear? Yes. Yes. Now one more thing. One more thing is that if you are going to modify the system, such as that initially the system was look like this. This was your initial system. This is person A, this was person B, and this was person C. This is A, this is B, this is C. This was the initial. Now let's rearrange it, that I'm redefining the boundaries of my system, and now this is the new boundary of the system. Then whatever the force applied by this, it's a F1 and this is F2. So now in this case, A, B and C are part of the system, and so force applied by A, that is of F1, and force applied by C, which is an F2, must be considered as internal forces. So there is nothing like internal forces or external forces. Before you define that which force is internal and which is external, you must define that what is the boundary of my system. If a force is applying by an agent which is within the system, that means it must be considered as an internal force. But if force has been applied by an agent which is not the part of the system, then that force can be considered, or that force would be considered as an external force. I hope those things are clear. Is it clear? Okay. One more thing. Balanced and unbalanced force. Now what is it? Balanced and unbalanced force. Let's have a look. Suppose this is the block, and from here you are applying a certain force, let's say a 5 unit or 5 Newton, 10 Newton, and from here it's a 15 Newton. So in which direction block is moving, whether it is in positive x or in negative x? Yes, you are correct that this box is not moving in any direction, because net force on a box is zero. So these forces are known as the balanced force. Is it clear? Now, what is unbalanced force? Let's have a look. The unbalanced force, that is that this is the block. You are applying a 15 Newton from here. You are applying a 5 Newton from here. So as this force is higher, my blocks is about to move in this direction. So in this case, this forces are considered as unbalanced forces, because net force on the box is non-zero. Yes, and when it is non-zero, when it is a non-zero number, then that can be considered as unbalanced force. So is it clear? Is it? Great. Let's look at one of the question. A ball of mass 20 gram is moving with a speed of 5050 meter per second. What amount of force is required to keep it moving with same speed? One more thing, assume that it is moving on frictionless surface. So go through the data very carefully, and try to answer this, that if a certain object is there and it is moving with a speed of 50 meter per second, then what amount of force is required to keep this moving with the same speed? Then if you remember the statement of Newton's first law, it says that if no external unbalanced force is acting on an object, then body at rest will try to remain at rest, and the body which is in a state of motion will continue to be in its own state. Yes, this is the statement of first law. And as they said that a ball is moving on smooth surface. So no force is acting on the ball. That means you require zero force to keep this ball moving. Is it clear? You require a zero amount of force to keep this moving. I hope these things are clear. Is it clear? Is it clear? Any doubts in this? Anything? Is there anything? No? Great. So let's wind it up this session. This was just the introductory session of Newton's first law. From the next session, we are discussing the Newton's second law and third law. Thank you. Have a good day. Take care. Bye bye.